Are you ready to take your data analytics and perhaps even your data science career to the next level? If so, you're going to need to know statistical analysis and data science. Hi, I'm Brian Amrine with Value Driven Analytics, and in this video, I'll give you a high-level overview of some general statistical analysis techniques and what that means, as well as some general data science concepts, and we'll go over a high-level overview of those as well. If that sounds good to you, let's head over to our PowerPoint. All right, now we're getting into data science. Let's talk about statistical analysis. At the heart of most statistical analysis techniques is the assumption of a distribution. In fact, there's a term for uh, models that use that. The term parametric means it's based on an assumption of a distribution. A lot of these techniques used a normal distribution or a bell curve. It's a very commonly seen distribution. Some examples of statistical tests include hypothesis testing, such as a t-test, or building a confidence interval for a metric, or even getting into certain types of regression. Now, in practice, I would say most analysts, especially outside of regulated industries like the medical industry, rarely take the time to actually apply a statistical test. Instead, it's often substituted for a general check to make sure that the difference is substantial. So one group, it's not saying, well, this group has a value of 100 versus 101. That's not a very big difference from a percentage perspective. And that each one of those averages or sums, that it's based on a sufficient sample. Maybe making sure that each group has based on at least 100 observations. So really simple checks on statistical significance, but not necessarily taking the time to actually compute a t-test. That's just not saying that's the right or wrong thing, but that's often the way it goes applying analytics at a lot of companies, especially your analytics level 1 and level 2 maturity companies. Now on the right side, I did want to show an example of a distribution and an example of a t-test or confidence interval. So we have our mean, our true mean here, and let's say that we pulled a certain sample and we found that the mean of that sample, the average of that sample, was up here, was 3 standard deviations higher than the true mean. Or a hypothesized mean. Our analysis would look at the likelihood that if we actually observed this kind of mean for a certain sample size that we have observed it among, what is the likelihood that the true mean actually is our hypothesized mean? And if it's a very low likelihood that we could see an average on a certain sample size that high, with the true mean being this level, if there's only a 2 or 1% likelihood of that being the case, we would often reject the null hypothesis and state that we are quite confident that the mean of the population is higher than the original hypothesized mean. Just one example of a statistical test. Now let's talk about data science modeling, which is sometimes referred to as machine learning or artificial intelligence. There's a fine line between all of those terms, and a lot of people think about them differently. So we'll combine them together for now at least. Now within data science modeling, there are predictive models and there are prescriptive models. Predictive models focus on making some kind of a prediction for the purpose of perhaps planning. How many sales do we think we're going to have next month so that we can plan our staff that's going to need to manufacture a certain amount of product? Or for prioritization, which consumers or which prospects do we think are most likely to buy so that we can make sure to call them first, for instance. And then when it comes to prescriptive models, we're trying to understand what is the causal relationship. Is there a causal relationship between variables? We might want to do this to calculate the return on investment. We need to know exactly how many sales a certain initiative is driving. Or perhaps we want to build a prescriptive model to identify ways to drive more or less of a particular variable, a particular thing we want to measure and understand. Now, sometimes organizations will employ a data engineer that we've talked about in order to build the data set, and then a data scientist to actually build the model. Now, in other organizations, it's kind of a all hands on deck approach where an analyst might be the one to create a visualization, perform an ad hoc analysis, build a model, build a data set for the model, all of the above. Every organization is different. There's different levels of specialization. Well, and there's also a lot of different types of data science models, and we have a few examples of those on the right here. So first we have a regression model. This is an example of a parametric model. A regression model relies on a certain distribution. If it's a linear model, it relies on the normal distribution. Then there's non-parametric models that don't rely on a variable having a particular distribution. A decision tree is an example of that. A random forest model is a more advanced version of a decision tree. It's a set of many trees built in a way to optimize what's called the bias variance trade-off. We'll talk more about that when we get into data science. And then there's neural network models or deep learning models, and those are some of the most advanced data science models that exist, used to do things like determine what's in an image or what sound something made, all kinds of things. And that's a quick overview of data science modeling. Again, we'll have a dedicated session to this later on in the series. If you like this video, I hope you'll consider liking it formally. And if you'd like to see more analytics, data science, and leadership training videos, please consider subscribing to the channel. Finally, if you have any questions on what we discussed today, please leave a comment and I'll try to respond to it as soon as possible. Thanks again for watching, and I'll see you in the next video.